Okay, as usual, please read this through and at least think about it or try it on your own before unpausing and watching and listening to me go through it. Okay, so here we go. This question is basically giving you a graph of a line as well as the coordinates of 2 points, and it wants the slope. All right, man, slope is definitely one of the big ideas on the Keystone exam. It's one of those reoccurring themes. You definitely need to know what's going on with slope, big time. And what the slope is rise over run. So slope is a fraction. It's a ratio. It's a comparison, but fraction. Slope is a fraction, and it's rise over run. So look, if you have a graph of a line, okay, one thing you just do is pick two nice points that you can like start just counting your rise and your run. So you can start and stop your counting, okay? So if we just go with these two dots, like that we know for sure are there and nice, and so look, we can just count. If we're going to do from here, start here and end there, looks like we would, for our rise, go up 1.5. And going up is a positive direction. So my rise I could think of as positive 1.5. And then I would have to go to the right, 1, 2, 3. So going to the right is also a positive direction. So my overall rise over run is positive 1.5 over positive 3. Not the nicest fraction to try to reduce, but that's going to reduce to 1 over 2. All right? Now, just kind of an FYI, if you were to say, maybe start counting at this point and finishing at that point, that's okay. It doesn't matter. That's fine. It's just that, I want to tell you that you'd be going down and then left, okay? You'd be going down, which is a negative direction, 1.5, and then you're going left, which is another negative direction, negative 3. So it'd be like negative 1.5 over negative 3, but that is also positive 1/2. A negative divided by negative is positive, okay? Now, at this point, I want to kind of show you how, or point out, or remind you that they want you to, they want the answer, which is 1/2, okay? But they want you to show or explain all of your work. And if you're just doing this counting approach, I think you're going to need to explain what you did and how you counted the rise and the run and all that kind of stuff and reduced. I don't know if that's actually what you want to do. I mean, knock yourself out. But I would probably emphasize this. Because normally, not only did they give you the actual graph of the line, they made it a point, no pun intended, they made it a point to give you the coordinates of 2 points. So when that happens, okay, so let me pause right there and say that again, okay? When you are given two sets of coordinates, the coordinates of 2 points, this is usually your go-to if you want slope, okay? This is the formula for slope that takes the ingredients of the coordinates of 2 points. So in other words, the ingredients for this formula is the coordinates of 2 points, which is exactly what we have. So, and by the way, this formula is on the Keystone exam formula sheet. So I guess you don't need to memorize it. It's on your formula sheet. So, I look at those coordinates and I would call my y2, let's just say it's 3.5. That is my second y coordinate, okay? My first y coordinate, my other y coordinate would be 5 then. And so that would make x2 3, okay? So again, like look up here. If I'm calling this y2 then that would be y1, and therefore that would be x2, and then we want to subtract x1, and so that becomes negative 1.5, or negative 1.5, over negative 3, which again reduces to positive 1, excuse me, over positive 2. And so there's your 1/2 again, and that would probably where, like, you know, you're showing your work, and that would count as showing your work, okay? Now moving on to part B, and you know, please try this, pause the video if you have to, read this over, and you know, so pause it so you can read it over and think about what you would do, please. Okay, they want the equation. This is a very common thing too with the keystones, okay? Knowing how to come up with equations of things. And again, show or explain all of your work. I would think if you were going to go with the showing, I'm sorry, I apologize. If you're going to go the route of explaining, that might sort of be when you look at your line and go, well, I mean, I know M, and if I can just look at my line, look at my graph, and figure out that just by looking at it, that my B value, which is your y-intercept, it looks like it's 2. You know, I think that's pretty safe to say. So, I mean, you could confirm that, but let's just go with that for now. So it looks like my B value is 2. Remember, B is your y-intercept. Your y-intercept is where your line is crossing the y-axis. So gang, if you know M and B, you can just plug it into y equals mx plus b. So there's your equation, but I think you'd have to like thoroughly explain that you looked at the graph and you saw that it was crossing the y-axis at 2, blah, blah, blah. So I think that's what you'd have to do to kind of like, you know, but you have to explain it. Showing your work, I think you can go this. I want to do this way anyway, you know, where you're going to have to like showing your work. So, okay. So we know M is 1/2. I want to talk about using this formula to come up with an equation of a line. Now, this formula is called point slope. This is also on your formula sheet. Point slope, well, guess why it's called point slope? It's called point slope because the ingredients, okay, the items, the things you see in this formula is, well, the coordinates of a point right there, x1, y1, that would be the coordinates of any point on the line, and the m would of course be what? Your slope. So literally that's why it's called point slope form. Appropriate name, I would say, right? So so basically, in a way, if you know a point on your line, and if you know the slope of your line, you have the exact ingredients to plug into this formula and come up with the equation of the line, period, okay? Now, let me go back here and kind of go, well, I mean, do we have the slope and a point? Yeah, we have 2 points. I'm going to choose 6, 5, okay? Just so I don't use the decimal, I guess. So 6, 5, let me write that down. Okay, so there it is. I have M as 1/2, and I have a point which I'm going to use as my x1 value and my y1 value. Remember, people, ordered pairs, you know, something, comma, something, that goes x, comma, y. So 6 would be my x1, and 5 would be my y1. So now all I really do is plug in the 5 for y1. Looks, again, plugging in 1/2 for m. And I'm going to plug in 6 for x1. Okay? Now you're probably wondering, what do I plug in for x and y? Nothing. X stays x, y stays y. So the only ingredients we're plugging in are for y1, m, and x1. All right, now let me talk about this really quick. Okay? Here's an interesting something to point out. They want the equation of the line. they did not specify if they wanted this equation in point-slope form, slope-intercept form, standard form, some non-form that's still correct. I mean, they didn't ask for anything specific. So guess what? You could stop right now. This should be a acceptable answer. Y minus 5 equals 1/2 times the quantity of x minus 6. So I hope you understand what I'm saying. They didn't specify. They just said, write the equation. They didn't say, write the slope-intercept form of the equation. Now, of course, because I want these videos to be really thorough and I want to review as much as possible, okay, let's pretend that they did ask specifically for the slope-intercept form. That's y equals mx plus b, okay? All we'd have to do to finish this off in slope-intercept form is first distribute to clear the bubble. So 1/2 times x is, well, 1/2 times x. It's 1/2 x. And then 1/2 times minus 6 is going to be minus 3. Now to finish putting it in slope-intercept form, which is basically getting y by itself, we would undo the minus 5, would get rid of the minus 5 by adding 5 to both sides. And so that leaves y all alone, which we want. And when you add 5 to the other side, you're only going to add 5 to the negative 3, you know, like terms and everything. So that'll be plus 2. Okay? So that's another way you could end this equation, or it's what you would need to do if they specifically were asking for slope-intercept form. Okay, now while I'm on a roll, I guess, it's like, why is this called slope-intercept form? Well, it's because 1/2 in this equation would be your slope, and the positive 2 would be your y-intercept. So it's not really hard to figure out why they call these forms what they do. Slope-intercept form and point-slope form. Okay, now, I don't know, I mean, why not? What if they somehow asked for standard form? Standard form is also on your formula sheet. And standard form, while I'm reviewing stuff that are just extra at this point, but whatever. Standard form is ax plus by equals c. Essentially, people, that just means you want the x term first, followed by the y term, followed by the equal sign, and then followed by just a constant. So x term on the left side, the y term, equal sign, and then the constant. Okay? If you wanted to finish this off in standard form, well, first maybe I'll just recopy down 1/2 x plus 2. Okay? We need the x term over on the left side. So how do we move the x term over to the left side? We subtract it away from the right side. So that's going to mean, and again, we want the x term first, so we're going to put negative 1/2 x plus y equals 2. So we just moved the x term from the right side to the left side, so it can be like in the proper order of standard form, okay? Now, plot twist here at the end. I know it's in the proper order now, like, see? I mean, again, we got the x term, and then the y term, and then the just regular number constant over here on the other side of the equal sign. But here's the thing. You're not really supposed to have fractions as your a value or your b value or your c value. And look, right now we have an a value of negative 1/2, and that's not really conventional, okay? Like, it's not what you're going to see as a final answer, like, say, on multiple choice. So here's what we do. We have to rewrite this and as this without using a fraction. So long story short, too late. How can we make negative 1/2 not a fraction? Multiply it by something like 2. But you know what? If you're going to multiply that by 2, you have to multiply the entire equation by 2. Okay, does that make sense? If you multiply negative 1/2 times 2, will that be a fraction anymore? I mean, like, what's 2 times negative 1/2? It's negative 1. And again, we also have to multiply the 2 to the rest of the equation as well. So that y is going to become 2y, and the 2 is going to become 4. Okay, now, did we need to actually write the 1 here? No. So negative x plus 2y equals 4. And another little side note, another way this could be written is positive x minus 2y equals negative 4. That would have been the same thing. Again, if you have any questions about that, feel free to ask me in class next time you see me. But another way to write this and still be correct is positive x minus 2y equals negative 4, okay? But again, so just to kind of summarize this, okay, they wanted an equation. This would have been just fine. This would have been just fine. This is just fine, okay? Like, they're all just fine, you know, but I just wanted to kind of point out if they specifically asked for standard form, if they specifically asked for slope-intercept form, you know, whatever. Part C. Of course, I want you to think about this for a second, maybe pause it before finishing the video. Okay, so they talk about plotting another line using points L and M, but the big idea is that the slope of our original line is going to be equal to the slope of line LM, the line that's that contains point L and point M. And this is describe 2 ways the lines could be related. So hopefully you've already thought about this. If not, pause it and please think, okay, like, what does it mean when the slopes are equal? How could these 2 lines be related if their slopes are equal, okay? The first big one is that the 2 lines are parallel. That is something to know on the keystones, okay? That's one of those facts that you got to know. If 2 lines have the same slope, that means they can be parallel, or the other way is that they are literally the exact same line graphed over top of each other. So there it is, the 2 ways, and you just got to describe that, okay? Using your words, using very thorough, clear verbiage, okay? That the 2 lines could be parallel or the exact same line.